Picture yourself at home. How do you feel? Safe? Grounded? Peaceful? What do you see when you think of home? A structure with 4 walls and a roof that house your favorite people? Maybe a beautiful landscape as seen on my slide. Regardless of what you see, your home and the life you live was built on the thin layer of soil that encircles the Earth's crust. These few feet are the very thing which life springs from, and it holds the memories of 1,000 lifetimes lived. As you look across the landscape, you can see the story of the glacier's retreat 11,000 years ago, overlaid by the story of a society who moved from hunting and gathering to farming. We can be certain the soil will hold the memories of our lifetime too. My research probes the thin layer of soil encircled in red in the center of the slide for the secrets it holds about carbon cycling. This soil layer was formed under native prairie when bison roamed the plains and became buried due to tillage and water erosion, moving soil from the tops of the hills into the lower slopes as seen by the red arrows when the land became farmed. This soil layer, called the buried surface horizon, is unique because it contains carbon that is resistant to loss as CO2. Understanding what keeps carbon stored in soils is crucial as we strive to achieve net zero emissions by 2050. Storing more carbon in soils is more challenging than simply adding more carbon. Carbon gets added to soil through plant photosynthesis and is then eaten by soil microorganisms like bacteria and fungi who breathe some of that carbon out as CO2. Those initial organisms die, and that carbon is eaten by another microbe who breathes some more out as CO2. And over until either all of that carbon is returned back to the atmosphere as carbon dioxide, or something happens that prevents microorganisms from eating it. As you can see by the figure on the right, soil is very complex, so predicting what will happen to that carbon is very challenging. Buried surface horizons are very unique because they are one of the few areas in soils that contain carbon that microorganisms are no longer able to eat. By studying this soil, I have been able to identify biomarkers, such as bonding of carbon to mineral surfaces, with more to come as my thesis progresses, that contribute to carbon stability, so that as we're trying to determine what practices support long-term carbon storage, we can be clear on what we're looking for. This research will help us store more carbon in soils, reducing greenhouse gases in the atmosphere, so that hopefully the soil will be able to hold the memories of 1,000 more lifetimes to come. Thank you.